In this video, we're going to be talking about adding segments and adding angles. So at the top here, we have what's called the addition property of equality, where if A equals B and C equals D, so I can almost write it like this, A equals B and C equals D, then it's true that A plus C equals B plus D just by adding those two statements. We have the partition postulate, which is the whole is equal to the sum of its parts, which we've used in Unit 1 and in other units. And the angle addition postulate, which says that we can add angles together, which is another idea of the whole angle is equal to the sum of its parts. Okay, so we're going to use these ideas to add segments. So say I give you that AB is congruent to CD. And I want to prove, so this is where I'm trying to go, I'm trying to show that AC is congruent to BD. In this video, we're going to be adding angles and segments. The first statement is what we call the addition property of equality, where if A equals B and C equals D, then it's true that A plus C equals B plus D by adding those two statements together. So the addition property of equality. Now the partition postulate and angle addition postulate are ideas of the whole is equal to the sum of its parts, and those are the ideas that we're going to use today to help us add segments. So in our first example, I'm giving you that AB is congruent to CD, and I want to show that AC plus BD, or excuse me, AC is equal to BD. Okay, so I want to show that this is congruent to this. Now what you can see between these two places where I'm trying to go, BC is included. Now BC is congruent to itself. So CD plus BC is going to be the same thing as AB plus BC. So then by some substitution, I can get that the whole AC is equal to BD. Okay, so let's write this out. So here are my givens. Okay, now like I said, we have to talk about BC. This is the congruent part that's going to be shared between these two segments. So BC is congruent to itself by the reflexive property. Now like we said above, I have two statements here where these are congruent and these are congruent. So if I add them together, AB plus BC, which is what AC is made up of, AB plus BC, it'll also equal CD plus BC, CD plus BC. And that's our addition property. Okay, so we're almost there. We got a couple more steps to go. I need to show that this equals AC and BD though. So in my next step here, I'm going to say AC, which is this whole segment, is equal to AB plus BC. And I also know that BD is equal to BC plus CD. And that's just the whole is equal to the sum of its parts. Okay, here's AB plus BC, here's AB plus BC, here's CD plus BC, here's CD plus BC. What I can do is take the BD and plug it in to CD plus BC because I know that those are equivalent. Likewise, I can take AC and plug it in to AB plus BC. So by doing that, I get AC is congruent to BD, which is what I was trying to prove all along, and that's just by substitution. Okay, in our next example, we're going to be adding angles. So I'm giving you that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And I want to show that BC, wait a minute. I want to show that ABD, there we are, is congruent to DBC. There we go. Okay, so I'm trying to show that this is congruent to this. Okay, so I got 1 and 2. I know 3 and 4 are congruent, so if I add these together and add these together, that would make up the whole angle, and then those would be congruent. So starting with what they gave me, like I said, I'm going to add 1 and 3, and I'm also going to add 2 and 4. 1 and 3, 2 and 4. And that's just our addition property. Okay, I should get ABD and DBC in my proof. So I'm going to talk about the whole is equal to the sum of its parts next. Angle ABD, which is this angle right here, is made up of 1 and 3. Okay, I also have DBC is made up of 2 and 4. Okay, so here is 1 and 3, here's 1 and 3. Here's 2 and 4, here's 2 and 4. So I can take ABD and plug it in for 1 and 3. I can take DBC and plug it in for 2 and 4. And that's just by substitution. So my last step here is that angle ABD is congruent to angle DBC. And that's substitution. All right, next, so PQ is congruent to RS, and M is the midpoint of QR. So if M is the midpoint, I know that these two little segments in here must also be congruent. And I want to show that PM is congruent to MS. So I'm trying to go here. Where is PM? PM, MS. Okay, so that's where I'm trying to go. Well, this is like adding segments. I know that PQ is congruent to RS. I know that these two segments are congruent after I obviously talk about the midpoint. So if I add these congruent segments together, this whole will equal this whole. Okay, so first our givens. Alright, so let's talk about the midpoint first. If M is the midpoint of QR, then I know that QM and MR are congruent. That's because a midpoint divides a segment into two congruent segments. Okay, now what I can do next is add some stuff together. So I'm looking specifically at this line in this line. I can get RQ plus QM because that's what's going to make up this whole segment. And RS plus MR. RS plus MR, that's the other segment. And that's just your addition property. Okay, now remember, I got to get PM and MS into my proof. So by doing that, I'm going to have to do the whole is equal to the sum of its parts. So PM is equal to PQ plus QM, and MS is equal to MR plus RS. Okay, so let's look at what we have in the proof so far. Here's PQ and QM. Here's PQ and QM. Here's MR and RS. Here's RS and MR. So I can take PM and plug it in to PQ plus QM. I can take MS and plug it in for RS plus MR because I know they're equivalent. And that's just by substitution. And that's what I was trying to prove all along. And then we're done. Alright, lastly here, I've got angle 1 congruent to angle 3 and AEC, so that's this whole angle is that's where I'm trying to go. Angle 1 is congruent to angle 3. I'm trying to get to show that AEC is congruent to DEB. So here's AEC, so that's like this whole angle here in pink, and then I'll do in purple DEB. Okay, so I'm trying to show that the pink angle is congruent to the purple angle. Now what both of these angles is going to end up sharing is angle 2. So I can get angle 2 congruent to itself by reflexive, add them together, and then I'll get the angles. Okay, so first starting with angle 1, I'm going to do this in black. Angle 1 is congruent to angle 3. Let's say angle 2 is congruent to itself, and that's just the reflexive property. Okay, now like I was saying, I can add 1 and 2. That'll give me this whole angle. I can add 3 and 2 as well, and that'll give me this whole angle here. So my next step is angle 1 plus angle 2 is equal to angle 3 plus angle 2. And that's my addition property. Okay, now remember I gotta get AEC and DEB into my proof, so I should talk about that and use the whole is equal to the sum of its parts. AEC is made up of angle 1 and angle 2. And then DEB is made up of angle 2 and angle 3. Okay, so here's 1 and 2, here's 1 and 2. Here's 2 and 3, here's 3 and 2. So I can take AEC and plug it in for 1 and 2. And I can take DEB and plug it in for 3 and 2. So that's my last step. Angle AEC is congruent to angle DEB. And that's just by substitution.